Good afternoon, everybody, and welcome again to a session on engineering graphics. I am Yash Chawla from Parul Institute of Engineering and Technology, and we are going to continue loci of points today, and we are going to complete that chapter today. Till last session, we completed 4 problems, and now we are going to discuss 3 more problems before we come to the end of this particular chapter. Thereafter, in the next week, we will move on to another chapter, that is engineering curves. So let's see what first problem has in store for us today. Loci of points, this is what the topic is, some more solved examples. Okay, now as I always say that we should read the problem very carefully before starting the solution. So let's read the problem first and then we will see the line animation. 2 cranks AO and BQ oscillate about O and Q. Now this particular sentence says that there are 2 cranks, one is AO, the other one is BQ. The first AO has its center O and the second BQ has its center Q. Now we have to draw the mechanism first and then we have to draw the locus of the midpoint of the connecting rod. Now both the cranks will be connected by a connecting rod, that is AB in this particular question, and its midpoint will be marked as, say, P, and we have to find the locus of this particular point. Now one more important thing that we should keep in mind is that it is mentioned that both the cranks are oscillating. So we know that this is 4-bar chain mechanism in which both the cranks are oscillating. So the figure would be formed according to that. Now the dimensions are given. AO is 450 mm, BQ is 675 mm, AB is 375 mm. Initial condition is given, that is angle ABQ is equal to 90 degrees. Now this importance of this particular angle ABQ is equal to 90 degrees will be realized once we start drawing the figure and we reach up till the point where we have to draw the crank BQ. Now one more thing I want to mention that I have not mentioned in previous lectures, that if you are not drawing these particular problems on say a sheet and you are drawing it in sketchbook, these dimensions that are given in the question the sketchbook might not be able to accommodate these dimensions. So you can take appropriate scale, as we had discussed in first lecture. Say a scale of 1 mm is equal 1 mm is equal to 10 mm, that is 1 mm on paper is equal to 10 mm of the question. So appropriate scale should be taken, and you should remember that if you have taken a particular scale, that particular scale applies to all the dimensions in the problem, not just one dimension. So that should be kept in mind. So now let's see the line animation of this particular question that we have read. Now this is a 4-bar chain mechanism in which both the links are oscillating. Now this is the first link, that is OA, and this is the second crank, that is BQ, and in blue you can see the connecting rod. The importance of these limits will be discussed further as we start constructing the problem and go on for plotting the locus. This is just for the understanding that what kind of the mechanism or what kind of movement this particular mechanism has. So let's move on. Let's start the first step. Now the first step of this problem is to take any point on the sheet, irrelevant of the space, but you should take it on the left hand side. So we will take any point and we will mark it as O. The problem begins from this particular point. So now what's the next step? Step 2. Now the first crank is AO. Its radius is its length is 450 mm. So I'll take 450 mm on my compass, put the center at O, and draw a curve. Now this particular curve has its own importance, which will be discussed as we move on. The next step. Now we have the center and we have the point. We have the curve. So now we will join any radius, that is O, up till the circle, end point of the circle, and we'll mark it as A. This OA is the first crank, that is going to be oscillating. The next step, again, now we have taken we have this crank OA. The next thing that we want to do is we want to draw the connecting rod. Now connecting rod is AB and it is 375 mm as it is given in the question. So we will draw from A, we will draw a line that is 375 mm long and mark its endpoint as B. Understood? So let's move on. Now here the importance of the angle will come. Initial condition in the question was mentioned that A, B and Q is 90 degrees. So why this angle 90 degrees? See, we have the position of the first crank. We have taken the position of AB. Now both these positions are assumed. So for the third point, or say the third link, that is the second that is BQ, that is the second crank, oscillating crank, its position has to be finalized and it should have a particular condition, otherwise that link can be drawn anywhere on paper. So that is why this particular angle ABQ is mentioned. So what we are going to do is we are going to draw a perpendicular to AB. From B we are going to draw a perpendicular or straight line which is 675 mm long, and then mark the end point of this particular segment as Q. Now this particular line segment BQ is at an angle of 90 degrees from with respect to AB, and this BQ is our second crank. So we have both the cranks and we have the connecting rod according to the specifications that are given in the question. Now the next step. Now we have this particular crank. Now we have to draw its path. So with radius equal to BQ, that is 675 mm, I will draw a long curve as I did for OA. Let's see. With center is equal to Q and radius equal to 675 mm, we will draw a long curve that you can see on the left hand side of right hand side of your screens. This is the first joint, second joint, third joint and fourth joint. O is our first joint, A is our second joint, B is our third joint and Q is our fourth joint. So we know that in a 4-bar chain mechanism there are 4 joints. So this fulfills the condition of this particular 4-bar chain mechanism. What next? We have 2 cranks, OA and BQ. So we have 2 cranks and we also have a connecting rod which is AB. So we have 3 links. All the 3 links are moving with respect to each other. We have 4 joints, so it becomes a 4-bar chain mechanism. Now this particular curve, I told you that it has its own importance. See, this crank OA will be oscillating, and it will be guided by this particular path. And in short, we can say that this particular curve which is passing through A is the locus of point A for the crank OA. A will be moving on this particular curve. Similarly, for the crank BQ, this particular path is the locus of B, or say this is the path on which crank BQ will be rotating. B will be following this particular path. Now what is the importance of drawing these particular arcs? See, initially when we saw the video, I told you that we will be marking the endpoints. So for particular A or B to oscillate, we need endpoints. So we will be marking the endpoints on these particular arcs. Okay, now the next step that we are going to take is, now we have the mechanism. Now for which point do we have to plot the locus? In the question it is mentioned that draw the locus for the midpoint of the connecting rod. Now connecting rod is AB, so its midpoint has to be taken. So we'll take the midpoint of the connecting rod AB and mark it as P, which is there on your screen right now. So this particular point P is the one for which the locus has to be drawn. Now both the links are oscillating, so there will be a positive extreme point and there will be a negative extreme point. That is an most upward position and the most downward position, or say the uppermost extreme point and the lowermost extreme point for both the cranks, because they are oscillating between a particular area. So we have to mark those particular points. Now we will look at the animation once again, and then we will discuss what radius and what measurements we are going to take. So as you can see that, say first we'll discuss about BQ. Now this link is oscillating between B dash, this is B dash, say this link comes here, then it changes its direction and comes down to B double dash, and then it moves again. So this, it is tracing B dash path. So we have to mark this B dash and B double dash. So how are we going to know this? So the question will be answered right now. So, and for OA, it is between A dash and A double dash. Now I want you all to observe a very simple thing that is there in this figure. See, when does this particular crank changes its direction? When this particular OA and this particular connecting rod come in a straight line. Similarly, when does OA change its direction? It is when this connecting rod and this BQ comes in a straight line. See, so we know that, now I'll just escape this. So I need to measure my connecting rod and my connecting rod as well as my crank. From that center I'll mark an arc on the other curve, so I'll have what? I'll have the extreme point for my other center. So now we'll take it first for, say, the extreme points of OA. For that I will take my I'll take my radius as BQ plus AB, that is a total of 675 mm, that is the length of BQ, and 375 mm, that is the length of AB, that is BQ crank plus AB, that is my connecting rod. So both this sum will come down to 1050 mm. Now with this particular radius and center as Q, I will mark an arc on the circle of OA at A dash and A double dash, which will give me, see, we will mark the arc here. From Q, I have taken the radius as BQ plus AB, that is the connecting rod, and marked an arc at A dash. Again BQ plus AB and marked an arc at A double dash. Now what does this these particular lines show? That this crank OA will not exceed this particular limit A double dash and A dash. It will not go beyond these particular lines. So I will have a particular region in which this particular crank OA will be oscillating. Now similarly, I want to mark the arcs for my BQ. So I will again take radius is equal to OA, that is my other crank, plus the connecting rod, that is 450 mm, plus 375 mm, that is 825 mm, and with that and center as O, I will cut an arc at B dash and B double dash. This is again OA plus AB and again OA plus AB. Now looking at this figure, you might wonder that the dimensions are not equal. I would like to say that I have not taken exact dimensions because PowerPoint has its limitation. So I'll urge you all that when you are drawing, please make sure that you cut the arcs and you take the dimensions very properly on the scale and on the compass, because if you don't take these particular dimensions carefully and accurately, your curve, the end curve that has to come, that is the locus, won't come as required. So now we have the limits of A, the oscillation of OA, and we have the limits of B, that is oscillation of BQ. So now what next? Now we need different positions of OA. With respect to that, we need different positions of AB, and with respect to that, we need different conditions of BQ. So for that, what we are going to do? For this, we will take, first of all, we'll take small radiuses. That is, on the compass, I'll say I'll measure 3 mm or 5 mm. The smaller the arc that you take, the more accurate will be the figure. And keeping the point as, let's see, keeping it on A, we will keep the radius 3 to 5 mm. Least to least radius will give you maximum accuracy. Now we will put my pointed end at A and cut an arc at A1, then put my pointed end at 1, cut an arc at 2, put my pointed end at 2, cut an arc at 3, 4, 5, 6, 7, 8, 9. Now you can see here that from the distance of A double dash from 9 is smaller than distance between 9 and 8. This is because I have not measured the arc and divided it into equal parts. I have just taken a random measurement and marked the arcs. So you have to mark the arcs till you reach this particular point A double dash. You don't have to mark arcs after A double dash, because my point A will not be able to exceed this particular A double dash. So this is my extreme point. Now why I have taken these arcs. Now these particular arcs, say 1, 2, 3, 4, 5, 6, 7, 8 till 9, denote the different positions of crank OA. Now for finding the locus, I need different positions of all the three with respect to each other. So now I have fixed OA. I know the position of OA for say 1 to 9, 9 steps. So for those particular conditions, I will draw my connecting rod, and according to the connecting rod, I will draw my the positions of my BQ. So finally I'll have all the positions of my connecting rod. Moving starting from A double dash, I'll move to A dash to A double dash, and then again I'll move from A double dash till A dash. So I'll have almost all positions of my crank. So I can take midpoints of those cranks in step by step, and then I can mark the locus of point P as required. So first step. Now we know that we have OA. Now next step is to mark the position of connecting rod. So for A dash, I'll first take the point A dash and take my radius is equal to 375 mm, that is the radius of the connecting rod AB, and then with center at A dash, I'll cut an arc on the curve. That is, I'll mark it as point A, and then I'll draw my A dash A, which is my position of the connecting rod when my crank OA is actually at positioned at A dash, and then I will mark the midpoint of this particular position of the rod, that is P dash. I'll give it name as P dash. So now again I'll perform the same actions from 1 up till 9. So let's see what is going on from 1 up till 9. So remember these two things. We have to mark the connecting rod, or say draw the connecting rod and take its midpoint till we reach A double dash. We should not exceed beyond that, and there should be no arcs cut from these